Hello, hello, hello. Is it working? I should see this on my YouTube page. Hey, we're live. Good. Okay. So I went ahead and read the enum section here. Since it's quite Haskellian, so it's gonna be kind of odd. So we'll see how it goes. Okay, section enum 2. Define the different messages used below. So we have move, echo, change color, and then quit. Okay, so quit doesn't seem like it takes any shit. Oh, there's a resize too. Oh. Resize. Now resize takes a point. Can I? So I can do like a. So this guy just takes a point. But this guy just, I don't. So what? I don't understand how to give it. Can I give it a width? Right. Width UA. The height of UA. Can I do it in this? No. Okay. So it's so this guy's gonna be a string. Or a string. Or string. I don't know. Still don't know strings in Rust. UA. Okay. So we gotta attach something. I could create a struct, but that if I create a struct, would that work? Because this guy's creating a struct like that. I just want to give it parameters. Oh, I can. That's exactly what I want. Oh, I did it. I did it like this. Okay, cool. Okay, so let's tackle the next question. We got, oh, let me just make sure we did this right. Oh, no. One, two, three, four. This is not. Is most common. What do you return? I guess that's the question. So you are a string. So I'm assuming it's going to be a string. So that's not a problem. Oh, it keeps. So now we're on 3. Okay, so that one's fine. Okay. Oh boy, there's some code here. Green and blue. So we got some implied state or implementation state. Okay. You got to create a match expression to process a different message variance using the method derived above. Okay, so I think it's like match message and then something. So match message, and then now, right? Yeah, coin. So then I can do message, and then I can just RGB. And then I would do this. Okay. And then that. What's my brain thinking? Then we can do this. What do we, I don't know. So what is this function? Process. Create a match expression to process different message variants using the method below. Oh, so I'm probably supposed to just I should probably just attach things to self is what I'm thinking I'm supposed to do. So what does, so we start off, I'm assuming it'll position will move directly to this. Okay, so echo. Okay, so this is, okay. Yeah, so it's just taking the, can I just take this as color? I don't want to have to do all of, but well, I don't have a concept of color at the moment, so. Let's put that back. Okay. So my messages, let's grab you. I don't know what I'm supposed to do for quit. Change color. Let's start off easy ones. Message, loop point. So self dot point or position. Echo. That's it. I don't know what's called stir. Self dot. Yeah, it's a little. Yeah, I've been there. Message. Lots of messages. Okay. Now let's see. I think it should probably help me out. I want to see. So with. So with. X is just a bool. Quit equals quit truth quitters. Okay, then so it's dot zero equals R, equals G, RGB. Yep. Color G equals blue. Cool. There might have been a better way to do that. I don't know. Oh, there's a change. Oh, I'd even. Oh, that's smart. I'd even rename these functions. Well, whatever. Waste of space. Waste of space. Okay. String. Oh. Gotta learn about strings. Still have no clue how those work. Alright, where are you at? Fix the compiler without changing the function signature. Clone. I should have no concept. I would have figured this would return the string. Okay. So where gotta do some reading. I have to do some reading. Okay. What is a string? There's that string from thing, so I wonder if I have to do that. I'll have to read this after. So let's try that. String from. Create a string from my string literal. Not entirely. I still don't. Still do not know. So here, I think I would do this. But this, I understand this because this is just a reference. No? Because it just wants to use it as a reference. It doesn't want to actually take ownership of it. Fine enough for me. Yeah, remove the white space from both ends of a string. I'm assuming these are all mutable, or am I supposed to return a new? So it is a string reference, so okay. So I need some tools here, bud. I need some tools. try this one. So this is supposed to take a new string and pump hello, or a world, I guess. Is this not a string? Strings are not so simple. To summarize, strings are complicated. Strings are complicated. Thank you. So this is the slice. White space? White space? I have no clue to do white space without like looping. I'm supposed to use a map? Okay, so this, since I feel like let's do something like this. And from what I just read, I don't think this would work either. Well. Okay, let's start. What is a string? Type in core language. Strings usually seen in borrowed form STR. String slice, which represents to some UTF-8 encoding strings, are stored in Perkin-Byron, therefore string slices. A string type which is provided by Rust standard library rather than encoded into core languages. A global mutable owned UTF encoded string type. In Rust, they might refer to strings or strings as string types, not just to those types. Although these sections largely are about strings, in Rust standard library, both string and string slices are UTF-8 encoded. Two string? What? What it? How is that not? In this line, we create an empty string called S into which we can then load data. Often we have some initial data with which we want to start the string from. From that, we use the toString method, which is available on any type that implements display trait. So string literals do this code creates a string containing initial content. Okay. Because strings are used so much, we can use many different generic APIs for strings. A lot of options. Some of them seem redundant, but they all have their place. In case from toString do the same thing, so which choose a matter of style and preference. Ending to a string with a push. Well, so this is not. I need. Can I do this? Let's try this. I want to use this as a reference, and then we're going to do let mute equals this. I can do that. Okay. And then I can do a dot push str world string. Then a return a. Okay, so that's what we're doing. Seems logical. Balloons. Okay, so I need something stronger than slice. Indexing, internal representation, slicing strings. Yeah. No, duh. Strings are complicated. Alright, let's get a hands on this one. This is gonna take me a while. Standard library function for strings. Let's try and use some of them. Trim. The trim function returns a string with leading and trailing white space removed. Oh, well, that's cool. So we can just do input dot trim. And then we can there should be a replace keyword, I'm assuming. There, placement, yep. Yeah, I was gonna say. Oops. Okay, so input dot replace cars with balloons. So this creates a new string. Okay, that's cool. So this modifies the string. This changes, makes a new one. Okay. Awesome. Is it not kosher to do that? Okay, where at? Okay, well, we got strings. What do you want with strings here, bud? Call function should be replaced with calls. This calls of this function should be replaced with calls of string slice or string. Okay. Here are a bunch of values. Some are string and some are reference to string. What is str? Oh, hold on. So hold on. Is I do let's a equals. Can I make less equals this? So that is a reference to a string. But if I did b equals to string, this is a real string. Now, what I can also do, c equals reference to b, which is, okay. Okay. Interesting. Placeholder with either string slice or string, depending on what you is. So this has to be this. To string has to be this. From string has to be this. To owned? What does this mean? To on, no, but it says the string. Into. What is into? Inferred in. I bet that one's sliced. Format. So this one is another. Once you screw around enough, you. Oh, is my stream down? Oh no, it's not down. Okay, we're good. Warning this byte index. Oh, maybe it is wrong. Hold on. Oh, it's an actual string. Okay. This is a byte index, not a character index. I have the feeling it's a slice. Not entirely sure. Trim was a slice. Okay, so this, I think this is what I'm trying. So this idea is like just like a reference plus size. Well, this is the actual string, literal, or string data, and this is a pointer to that string. So that's this. This is still a. This isn't actually modify necessarily anything. Okay. So this does modify. This is. And I'm assuming this also does modify. Because it has. Okay. So this can turn a dot string because it can. It's not changing the data, right? While these are replacing and changing the case. So they have to return a new string. time because they're not inherently immutable things. Sick. Okay. Modules. What about modules? Make sausage. Make sausage. Extender. That's me. Calling a private function. What the fudge? What's so? Is this a module? It's just a class with no functions on it? Is that what? Is this like a namespace thing? What are modules? By grouping related functions, separate code with distinct functions, we can clarify the code and the implementing the practical feature where it goes. Cargo workspace section. Okay, so let's go back here. So make sausage, the pub. $41. Oh snap! I'm only 40, 94. That's a few away from halfway done. Nice. Okay. Okay. Fix the compiler error without calling a private function. Don't let anybody outside of this module see this. Oh, that's what I just did. Okay. You can bring module paths into scope and provide new names for them with the use or as keyword. Oh, okay. Alright. Oh. Where do I put these? So these have to be public. Pub. Oh, but these are pub. Is that because it's in the pub? So I don't think they wanted me to do it like that. Let's try this again. Maybe put Interesting. Okay. Kind of an oddball example. Modules. Okay. Did it right. That's good. You can use the use keyword to bring module paths from modules from anywhere, especially from standard libraries, into your scope. To do, bring system time and Unix epoch from st time module in your scope. Bonus style points to be just one line. Okay. Okay. Let me pull this up and pull you up. So, let's see what I did. So I did use the word use. System time. Oh, SCD time. Oh. Now where's system time? What is that? Okay, well, we're gonna tackle this one at a time. System time as system time. Okay, so what was the secret there to do a one line? Oh, cool. Nice. Very handy. Okay. Damn, we're crushing it. 3 things done. Better than yesterday, yeah. Okay. 20 minutes. 20 minutes. I can't even think. 94 divided by 2. Oh, not gonna happen today, but we'll keep chugging. Hash map. Everyone's favorite maps. A basket of fruit in the form of a hash map needs to be defined. The key represents the name of the fruit and the values represent how many of that particular fruit are in the basket. You have to put at least 3 different types of fruit, apple, banana, and mango, in the basket, and the total count of all the fruits should be at least 5. Oh, okay. So, well, I'm guessing the hash map. Yep, it's gonna be this. How do you produce an empty hash map? So I'm assuming if I do this, it's gonna be like, you suck. Yeah. Yes. We're done. Oh, really? Okay. Okay. just default it? I don't know how to do a hash map. Do some hash browns. Okay. Boom. Different types of fruits. Mango, banana, apple, mango. What's another fruit? What's the second most fruit I buy? Oranges? So they have a lens keyword, a value.sum. Oh, that's cool. Oh, interesting. Alright. Okay. We are collecting different fruits to bake a delicious fruit cake. There's no such. The fruit cakes. Oh, let me just make sure I'm thinking fruit cakes. One of those are the things people like despise. Oh, okay. Okay. Well, that's orange. Oh, let's see what we got. Almost to the halfway of this thing, though. Which I guess is halfway in general. Alright, what do you get? We're collecting different fruits to make a delicious fruit cake. How many of the pickled fruit have we collected? 3 types of fruits, apples, mangoes, leeks. I know what these are. I just don't know what these are. Oh, I have no clue. Where do you eat these? What do you eat? Look like shitty grapes. Okay. Or no, shitty olives. You must add fruit to baskets so that there is at least one of each kind and more than 11 in total. We have a lot of mouths to feed. You are not allowed to insert any more fruit that are already in the basket. Apple, mangoes, and leeks. Okay. What? What's my criteria? 5 types of fruit. So they're just gonna... so I have to add it into the basket itself. Okay, so basically I need like a find keyword, and then if it's not in there, then I can just slap some fruit in there. Okay. Okay, so there's insert update. If the key isn't entry. Okay, so it looks like basket.entry of fruit or insert pool 30 fruit. That work? Maybe not. I thought this would make sense in my brain. If or insert, to me sounds like if that thing doesn't exist, if it doesn't, we want to insert 50, and if the same name using the entry API, the or insert message on entry is defined to return a mutable reference. It is much cleaner than writing the logic ourselves. In addition, plays more nicely with the borrow checker. Running this code, we'll put 50, yep, while inserting the key for the yellow with the value 50, because yellow doesn't have a value. Okay. Perfect. So I think this in for fruit, in fruit of kind, we check to see if fruit exists. If it doesn't, we add 30. Makes sense to me. So, okay, so they have this thing. Where does it fail at? Okay. We have to do more? Oh, I'm still on the stupid... Okay, no, it did work. Okay. And if the scores, 1 per line, of a soccer match is given, each line is of the form Team 1, Team 2, Team 1 goals, Team 2 goals, English, France, 4-2. We have to build a score table containing the names of the teams, total number of goals, the team scored, and the total number of team conceded. Okay, got it. Draft structure. Okay, build the tables. The extracted details. Keep in mind that goals scored by Team 1 will be the number of goals conceded. Similar goals. What is happening? Okay. What? So they have these scores. So I'm just supposed to push the scores? Is that what I want to do? Team scores, which is this? Why? That's probably make more sense tomorrow. So what we're gonna do? What are we going to do? What I want to do? I wanted to go back to the strings for a bit. Strings. Is that there are three relevant ways to look at strings from Rust's perspective. That's bytes, scalar values, or grapheme clusters. What the hell? What does this mean? Grapheme clusters. Documentation. A cluster of symbols that together represent an individual character that the user will see within a string on a screen. It is generally comprises a base character plus what Apple calls combining marks and are used, for instance, when there is no available precomposition single Unicode character that might do the job. When grapheme clusters are used in strings, you have to take special care that any function using from substring example are able to properly demarcate the boundaries between clusters. Okay, interesting. Okay, if we look at the word Hindi written in the Devanagari script, it is stored as a vector of U8 values and looks like this. That 18 bytes and its computing ultimately stores this data. If you look at them as Unicode scalar values, which are stored, or what Rust char type is, those bytes look like this. There are 6 char values here, but the 4th and 6th are not letters. They're diacritics that don't make sense on their own. Finally, oh, interesting. So this ties in here, and this ties it together, I guess. No, is this? No, but that's that. That is not that letter. Okay. We get person called the fourth letter that makes up the Hindi word. Rust provides different ways of interpreting the raw strings that computers store so that each program can choose the interpretation it needs no matter what human language the data is in. A final reason Rust doesn't use to index into a string to get characters, the indexing operations are expected to allow state constant time, but it isn't possible to guarantee that performance with a string because Rust would have to walk through the contents from the beginning of the index to determine how many valid characters there were. Interesting. Can't say I 100% understand that. Oh, that's cool. So C and the strings to explicit by character or bytes. Print out the 4 bytes that make up the string, but be sure to remember that valid Unicode scalar values may be made up of more than 1 byte. Getting grapheme clusters from strings with the Devanagari script is complex, so that the function is provided by the standard language create IO. Oh, wow. That's a lot of crates. It's just for lols. Let's see, how many is NPM? Number of packages. 3.1 million. So it would take 20 times, essentially. 20 times the amount of crates are on NPM. Wow. Any good? Probably not, but that's fine. Well, I would be intrigued to know how many of those are still useful. Like, because JavaScript moves so fast, like, wow. Strings are complicated. Yes, indeed. Slicing strings. So we went over this. Yeah, what is UTF-8? I thought UTF-8 was... I thought that was... Yeah, that's what I thought. UTF-32. So when it says is that there are actually 3 values in the string. But if it was a UTF-8, so if Rust uses why are there chars 8 4 bytes? Is a single unit K which needs strings in Rust are stored in byte trace encoded at UTF-8, which means take up 1 byte unless they're going to ASCII range. C just ignores this, and strings in Rust are stored as byte arrays encoded in UTF-8, meaning characters usually take up 1 byte unless they go out of ASCII range, and then they can take up 4 bytes max. C just ignores this, and a char is a single byte because C doesn't care about how your string is encoded and just uses bytes to represent it and leaves it up to the managed encoder. Okay, interesting. Okay, I think we're good. I think we've accomplished everything I needed to accomplish. So what do we tackle today? This is day 3. It's day 3. What does day 3 include? Sure, I don't care. So we got hash maps. So the enums. Oh man, I really crushed it. I really crushed it today. So enums, which can hold values, of values of different types. So there's pattern matching. Those are pretty cool. So string versus reference to string. That was a good one. Modules. Modules are kind of lame. But you use the keyword use to grab data from modules. That's pretty key. And then hash maps. So we did some hash map stuff. I didn't learn too much from that, but it's good. All right, accomplished. Day 3 done.